Hello my dear students, welcome to the lecture on oscillator. In this lecture we will learn about oscillator, tuned connected oscillator, Colpitt's oscillator, Hartley oscillator, crystal oscillator, tuned amplifier, and also the tuned amplifier. In that stage we will learn about single tuned amplifier, double tuned amplifier, class C power amplifier. So what is oscillator? An oscillator is a device, electronic device that generates oscillations of desired frequency that generates, that means that's a frequency generator type thing. So it's an electronic device that generates oscillations of desired frequency, that is known as oscillator. Oscillation means the ups and downs of a frequency of a signal, and high frequency means that will be very close, that will remain in a very close proximity, and that is the oscillation, and that is probably known as the oscillator. Now you can see that there are two types of oscillations. In that case we will learn about the damped oscillation and the undamped oscillations. There are two types of oscillations are there. Damped oscillation means that in certain time period of time the oscillation just dimmed, or whose amplitude goes decreasing with time. That means that fades with time, that has just what can I say, that just loses power after transmitting. That is known as the damped oscillations. But undamped oscillations or undamped oscillators, a type of oscillations whose amplitude remains constant with time. Here you can see that is the portion of the undamped oscillation, and that is the damped oscillation. Now coming back to the fact that the oscillator, a circuit which produces electrical oscillations of any desired frequency is known as an oscillatory circuit or tank circuit. That means the circuit which produce this kind of electrical oscillations, okay, of desired frequency. As you can see, there is a LC circuit, the inductor capacitor circuit. While the switch is on, the inductor creates the after electricity passes through, in the inductor there is a magnetic field that has been created here, and that is a capacitor. And here you can see that in capacitor there is first the charging mode, that is on the charging mode. After charging, the capacitor also acts as a voltage source. Then it will again charge the again charge the inductor, and we will get the electric field again. That is the thing, that is the thing, that a circuit which produces electrical oscillations of any desired frequency is known as an oscillator circuit or tank circuit. And you can see here there is the frequency of oscillations. That is the frequency of oscillations. The theory, the law is to calculate the resonance frequency is Fr is equal to 1 by twice by root over LC, and the I maximum and I minimum, it is a damped oscillation. That you can see that after the time that just slows down and decreasing its amplitude. Now an amplifier with proper positive feedback can act as an oscillator too. So an amplifier could be act as an oscillator. It can generate oscillations without any external signal source. Thus here you can see there are two voltage, that is input voltage and output voltage. It is a 180 degree phase shift amplifier, and there is a 180 degree feedback network amplifier. So in that kind of a sense, in that kind of a circuitry, you can see if the signal enters through in the V input, here you can find out the V output. That is 180 degree phase shift amplifier. So the input shifts just 180 degree. That means the vice versa, the reverse voltage that will be in the output. After going through to the feedback network, we again get the feedback voltage, which is 180 degree phase shifter, we will get again the same feedback voltage. But after going through to the amplifier, here you can see that the amplitude that increases, but that is flipped because 180 degree phase shifter are included here. It can generate oscillations without any external signal source. That is the characteristics of this kind of oscillators. Now going back to the another source of thing that we know now, there are three type of oscillators that we are dealing with. The three type of oscillators are like that. We can use the tank circuit as an oscillator, an amplifier as an oscillator, and a positive feedback as an oscillator. So in that sense, here you can see that a tank circuit is the tank circuit and an amplifier, transistor amplifier, and a feedback circuit component. The total system has been connected with each other, and that is can also be used as an oscillator. So there are another part that is the classifications or types of oscillators. There are the types. First of all, tuned collector oscillator, Colpitt's oscillator, Hartley oscillators. So they are the named because of some scientists. Phase shift oscillator, that means 180 degree phase shift oscillator, 90 degree phase shift oscillators, Wine bridge oscillator, and crystal oscillator. These oscillators are quite been used in the microcontroller sections, that you use a certain kind of a crystal that you choose from the market. That is look like this, the two port steel type component, and here is